Hello students, welcome back. Myself Uday Soni, Mathematics faculty for IIT JEE Main and Advanced. Let us start inverse trigonometric function. Before I start lecture 2, I am telling all the students, those who have not seen lecture 1 of inverse trigonometric function, please see it. I have given the link of lecture 1 in the description, okay? So let me start today's lecture. See, rundown of lecture 1 means we will try to recall lecture 1, okay? What I have taught you in lecture 1. I have taught the different graphs, isn't it? For sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x, and sec inverse x, isn't it? So here in this lecture I have classified them, okay? How to remember the domain and range. Look here, these two functions, sine inverse and cos inverse x, they both have got domain -1 to 1, so I have grouped them together, isn't it? So I have grouped them together. Tan inverse x, cot inverse x, they both have got domain -infinity to infinity, means they both have got domain all real number, so I have grouped them together. The third group is cosec inverse x and sec inverse x, they both have got the domain -infinity to -1 union 1 to infinity, okay? So I have grouped them together, okay? This is classification of inverse trigonometric functions based on their domain, okay? Now we will see how we can remember their range. Look here, according to range I have made again some groups, okay? But according to range I have made two types, okay? How we can remember, na? See, -pi/2, pi/2 type. In this type you will have three inverse trigonometric functions. First one is sine inverse x, the second one is tan inverse x, the third one is cosec inverse x, okay? See the range. Here we have got -pi/2 to pi/2. Here also we have got -pi/2 to pi/2, isn't it? But the difference between them, what is the difference? Here in case of sine, it is closed bracket, okay? Both -pi/2 and +pi/2 are included, but here it is open bracket, okay? They are not included, the extreme values are not included. And in case of cosec, look here, I'm excluding 0, since in output of cosec inverse x you will never get 0. I have shown this true graph in my previous lecture, okay? Here also you can see I have drawn the graph, a rough graph of all the three inverse function: sine inverse x, tan inverse x, and cosec inverse x. Here you may see that you are not getting any 0, isn't it, in cosec inverse x, so 0 is excluded. In this three graph, try to notice, is anything similar in this three graph? Yes, isn't it? They all are what? Anti-symmetric about origin, okay? 0, 0, anti-symmetric about origin. Now let us see the other one, okay? The other one is 0, pi type, okay? The first one was -pi/2, pi/2 type. Now this is 0, pi type. Functions are cos inverse x, cot inverse x, and sec inverse x. Group these three together, okay? And you see the range. Here you have got 0 to pi, close bracket, both. Here you have got 0 to pi, both are open bracket. And in this case also you have got 0 to pi, but in between them pi by 2 is excluded, since at pi by 2 sec inverse x is, you don't have any output. Okay, you may see from this graph also. Again, I have drawn the graph of cos inverse x, cot inverse x, sec inverse x, isn't it? I have drawn separately a rough sketch, so that you can remember. Okay, you please try to remember all the 6 inverse trigonometric graph. Okay, and this graph, is there anything similar? Yes, isn't it? They all are crossing 0 comma pi by 2, so they are anti-symmetric about 0 comma pi by 2. I would like to make a note here that this 0 comma pi by 2 is not a range, okay, and not from 0 to pi by 2. It's a coordinate, okay, it is a point on the graph. So be sure that it is not from 0 to pi by 2, but it is a point on the graph, okay, 0 comma pi by 2. This one, okay. This was what I was trying to explain. Okay, I told you in my previous lecture that I would summarize. Okay, so now in this fashion, by grouping, you can remember the domain and the range of ITF. Okay, inverse trigonometric function. Okay, now let me move on to the next page. Oh wow, here you have got a beautiful a blank page. A blank page is very beautiful, isn't it? You can write anything you want. So let me write what I want, and what you need I'll write here. Okay, anti symmetric about A comma B. Okay, anti-symmetric about A comma B. You were hearing the word anti-symmetric, isn't it? A couple of seconds back, I mean couple of minutes back, you were hearing about anti-symmetric. I was telling you, right, what are the common in these three graphs. So anti-symmetric. So now let us understand what this anti-symmetric is. Okay, how can we find the anti-symmetric? Look here, understand anti-symmetric. Okay, why it's very difficult for me to draw a vertical line, since I broke the screen of my iPad, so it's very difficult to write now, and since it is locked down, so no chance, isn't it, to get a new tempered glass or to replace my screen. I don't know what has gone wrong. Anyway, come here. This is not good. Let me rub it. Let me make a more clearer picture here. Okay, this is your coordinate axis and your graph. This is any graph. Okay, f of x. Now suppose this point is A comma B. Okay, so I hope everyone understand how this A comma B comes, isn't it? This is dash line. Okay, here you have got a point A, okay, and here point B, means at A the value of the function is B, isn't it? F of A is equals to B. So suppose I move a distance x unit on the right and x unit on the left. What is the corresponding point on the graph? Here, this point means the value of y. What is the value of y? F of A plus x. See, this is nothing but here I am moving x unit, isn't it, to the right of A. So if I'm moving x unit to the right of A, this point will be A plus x, isn't it? Since from origin till here you have got a distance of A unit and this distance is x, so this point will be from origin to this point, it will be A plus x. Now look here, I have moved x unit to the left of A, isn't it? So here also you will be moving. Make sure you make dash line, okay? These are not in the main graph, okay? So what is this? Again I'm moving x unit to the left of A. So what will be this point? This point will be, say, what will be this point? It will be A minus x, isn't it? Let it be. This point will be A minus x. So at A minus x, the point on the graph will be f of A minus x, okay? Now I hope everyone is understanding, right? Up to here you have come A, okay, from origin, and this unit is x. So this, what will be the length of this portion? Total minus x, isn't it? Total is A minus x. So this point is A minus x, and corresponding point on the graph is f of A minus x, okay? This is the value of y, okay? Y equals to f of A minus x, and this is your nothing but origin 0, 0. Now let us note one thing. See here, f of A plus x plus f of A minus x. What will be the value of this expression? F of A plus x. Since the graph is anti-symmetric about A comma B, so the height, suppose this height is h, then this height will also be h, isn't it? Because it is anti-symmetric about A comma B, and we have moved a distance of x unit to the right and x unit to the left, okay? So okay, so what is f of A plus x? Till here you have got a length of B, isn't it? So f of A plus h, total will be B plus h, isn't it? Now listen very carefully, come here. What will be this length? F of A minus x, this one. Again the total height till here is B, and this height is h, okay? So from total, if you minus h, you will get this height, isn't it? So this is plus B minus h, okay? These two is getting cancelled out. Here you have got 2b, okay? F of A plus x plus f of A minus x is equal to 2b, okay? Now let us move on to next page. Let me clear this. Anti-symmetric about 0, 0, okay? See, let me take you the first one. See the graph of sine inverse x, tan inverse x, cosec inverse x. What were these? Anti-symmetric about origin, okay? They were anti-symmetric about origin, and these three graphs were anti-symmetric about 0, pi by 2. We will see each graph one by one, okay? Now let me come to the point what I was telling. Anti-symmetric, okay? Anti-symmetric, what? Anti-symmetric about 0, 0, okay? 0, 0 means in place of A you have got 0, in place of B you have got 0. So right, putting okay, putting a equals to 0 and b equals to 0 in equation a. Okay, which equation? A. Where is a? Let me mark this as equation a. Okay, this is our equation a. So when we put here 0 0, the first one was f of a plus x, means 0 plus x. The other was f of a minus x, means 0 minus x, is equal to, say, 2b, right? 2 into b is 0. So you got f of x plus f of minus x is equals to 0. F of minus x is equals to minus f of x. Okay, when you replace x by minus x in any function and you get minus f of x, okay, minus times of that functions, then these functions are anti-symmetric about origin, or they are also called as odd function. Okay, this is the condition for odd function. Okay, odd function. Odd function implies what? F of minus x is equals to minus f of x. Okay, remember, I will teach you this in detail. I will be giving very good examples of odd functions in detail when I start what? A function chapter called function. Okay, this is inverse trigonometric function. So for now, just remember that f of minus x is equals to minus f of x. When this condition is given, your function is odd function, and in this case, for odd function, the graph is always anti-symmetric about origin. Okay, now look at what? Anti-symmetric about 0 comma pi by 2. Okay, the other three graphs of cos, cot, cos, cot and sec. Okay, they are anti-symmetric about 0 comma pi by 2. Let us understand this. Okay, you have to remember this one. Okay, it's very important. For odd function, the condition is f of minus x equals to minus f of x. Okay, now even function, not even, anti-symmetric about anti-symmetric I request student to give a feedback. Okay, and ask question from any topic, any chapter you are studying. You can ask question from that. And for those who are new to class 12, please see the lecture very carefully. Okay, and start practicing questions from your coaching or school package, any package, any book you can study. And if you have got doubt, please inbox me your doubt. Okay, in Facebook or here itself in the YouTube, you can comment me. Anyway, anti-symmetric about 0 comma pi by 2. Our three graphs were anti-symmetric about 0 comma pi by 2: cos inverse x, cot inverse x and sec inverse x, isn't it? So in case of here, write it down, putting a equals to 0 and b equals to pi by 2 in where? Equation a again. So f of a plus x means 0 plus x plus f of 0 minus x is equals to 2 times of b. What is the value of b now? Pi by 2. So you got f of x plus f of minus x is equals to pi. This 2 is getting cancelled out. So what is f of minus x? Pi minus f of x. It's very hot these days, right? Hold on. Okay, let me drink a cup of water. Done. So anti-symmetric about 0 comma pi by 2. Okay, anti-symmetric about 0 comma pi by 2. The condition is this. Okay, if you put minus x, listen carefully, if you put minus x in the given function, okay, and it comes out to be pi minus f of x, then the graph is anti-symmetric about that point, okay, given point. Anyway, the graph is anti-symmetric about 0 comma pi by 2. If this condition is given, okay, if the condition is given that the graph is anti-symmetric about some point, this point 0 comma pi by 2, then you can write this condition. Okay, and we all know that graphs which are anti-symmetric about 0 comma pi by 2 are cos inverse x, cot inverse x, and sec inverse x. They are anti-symmetric about 0 comma pi by 2. So in that three graphs you have to use this, okay, this condition. Now let us start our topic. Okay, man, I will explain you in such a type that you understand how to derive the formulas. Okay, now people in this topic, students find very difficult to memorize the formula and they forget very often. Okay, come here. Type. Okay, I will explain type by type. The first type is, write it down, type 1. Okay, type 1. In short, I am writing in short everything. Okay, this is T inverse, means trigonometric inverse. Okay, means sine inverse, tan inverse, cot inverse. Okay, trigonometric inverse of minus x is equals to the same function trigonometric inverse of x, but minus in front. Okay, or the other, in type 1, trigonometric inverse, okay, of minus x is equals to pi minus trigonometric inverse of x. Okay, T inverse means it may, in place of T, it may be sine, tan, cos, sec, anything. Okay, the 6 T ratios. So let me explain one by one. Okay, type 1, for sine, these are standard results, okay, formulas which you need to keep in mind. Sine inverse of minus x is equals to minus sine inverse x. The other one, tan inverse of minus x equals to minus tan inverse x. The third one, what? Just now I taught you, right? Group these three, sine, tan, and cosec, as one, and they all were anti-symmetric about origin. And for anti-symmetric about origin, I've just derived the condition, isn't it? F of minus x means in input, if you replace x by minus x, your output will be minus of f of x. Okay, it will be equal to minus f of x. The same thing I'm doing here. See, cosec inverse minus x means minus of cosec inverse x. Okay, I hope everyone is understanding. Okay, if anyone have got doubt, please do feel free to ask. Okay, let me move on to the next page. I'm finding very difficult. This is cos inverse minus x. Okay, so cos inverse minus x and cot inverse minus x and sec inverse minus x. Can anyone say these graphs were anti-symmetric about 0 comma pi by 2? And what was the condition? Pi minus f of x, isn't it? Just now I derived this also. Look here, f of minus x equals to pi minus f of x. When when the graph is antisymmetric about 0 comma pi by 2. So here you can write pi minus cos inverse x, pi minus cot inverse x, pi minus sec inverse x. And remember, these things you have to remember as a formula, okay? I'm just showing how it came. It doesn't mean that in exam you start deriving, okay? You have to memorize it. And in case if you forget, well, you know the trick, right? Antisymmetric. So you can derive from there. How easy it is, isn't it? So you can, for increasing the speed, you need to memorize something, okay? Or else you can derive all the formulas, isn't it? See, it is easy, okay? Now let us move on to type 2. Type 2. In type 2, again, this is trigonometric inverse 1 x, and here t2 inverse x. t1 t2, it is just differentiating, okay? That here if I've given you sine, then here you may get tan, cot, the other trigonometric function, okay? Means they are different. In type 1 they were same, right? Here was cos, here again you got cos, cot, cot, sec, sec, but here you will get other trigonometric ratio, okay? Hold on, I made a mistake here. It is 1 by x, okay? Trigonometric inverse of 1 by x equals to trigonometric inverse of x, okay? Now see here, sine inverse 1 by x. Sine inverse 1 by x is equal to cosec inverse x, okay? And here your domain should belongs to minus infinity to minus 1 union 1 to, you have to choose your domain in such a way that both left side and right side it is satisfying, okay? Getting? It should not come out to be not defined, okay? Any side. Look here, cos inverse 1 by x, not cos, okay? Cosec. Cosec inverse 1 by x. Now you can write here sine inverse. We all know na, that sine and cosec are reciprocal of each other, so I'm just reciprocating their input, okay? I will explain you how it comes. Here what x belongs to minus 1 to 1 union, what union, excluding 0. You cannot put 0, since when you put 0 here it becomes 1 by 0. So cosec inverse infinity, not defined, okay? 1 by 0 is not defined, so please exclude 0, okay? This is your type 2. Let me give you one more example. Cos inverse 1 by x comes out equal to sec inverse x. Here x belongs to minus infinity to minus 1 union 1 to infinity, okay? Union 1 to infinity, okay? And sec inverse 1 by x is equal to cos inverse x. Here your domain will belong to -1 to 1 minus, again 0 is excluded because you cannot put 0 here, right? 1 by 0 again it become not defined. So when you choose this domain, okay, it should satisfy both left side and right side. You cannot take here cos inverse -1 to 1 because from -1 to 1 again this is not defined. So you need to choose in such a way that both left side and right side your domain is satisfying. Okay, now a very simple thing, let me tell you how we are getting right. Sine inverse x, sine inverse x, 1 by x. Okay, suppose I'm taking this as theta. So when sine comes this side, it become 1 by x, means sine theta is 1 by x. 1 means perpendicular by hypotenuse. Okay, so from this triangle what will be your cosec theta? It will be hypotenuse by perpendicular, isn't it? They are what? Reciprocal. Okay, it is hypotenuse by perpendicular. So what will theta come out from here? Cosec will go the other side, cosec inverse x. Okay, getting my point? So in place of theta here in place of theta you can put cosec inverse x. So it comes out to be cosec inverse x is equals to sine inverse 1 by x. Okay, in the similar fashion, by drawing the triangle you can find the remaining one. Okay, the remaining three, there is cos inverse 1 by x. Okay, I mean cosec inverse 1 by x, cos inverse 1 by x, sec inverse 1 by x, isn't it? These things come from this concept. Okay, by drawing the triangle, taking the inverse function as theta and drawing the triangle and finding the other. See, one more thing, here I have written t1 and here I have written t2, isn't it? So here is sine inverse x and here you are getting cosec inverse x. They are different, right? Not like the previous one. Okay, so for today this much is enough. In my next video I will be teaching you type 2, type 3, type 4, and you will learn how to memorize the formulas. Okay, just remember the type and it will be very easy for you to keep things in mind. Okay, anyway, thank you students. See you in my next video. Bye bye.